First lesson 2.0, factoring reviews. This is our unit on rational expressions and rational equations. So you did this a lot in grade 11. So let's take a look if you remember what's going on for factoring. So this one's called greatest common factor. When we factor out things, we divide each term by them. So it's called our greatest common factor when we divide it out of each term. We place it on the outside of brackets. Then we divide everything by that, and the answer to dividing goes on the inside of the bracket. Okay? Now, always factor out your lowest degree of your variable. Now remember, the variable, in order to factor it out, has to be in every term. So let's take a look at a couple examples. What would be our common factor on the first example here? Okay, they can both divide by 3. Do they each have an A and a B? Yes. Okay, so you're going to divide each by A and B. Now, how many A's and B's can you take out of each? One only. It's always the least amount. Okay, and on the 12, there's an A1, B1. Okay, so you need to take the minimum amount of letters out. Okay, so that's what we would divide out. That would be called our GCF. Now, if I actually did the question, it just has a comma between them. It's not asking me to solve the actual question. But if it did ask me to solve the question, I would do it this way. I would put 3AB on the outside of brackets. Now I would divide each by that, and then put my answer to the dividing on the inside. So now, if I take 12 divided by 3, I get a 4. The A's and B's disappear because 1 subtract 1 is 0. Take 15 divided by 3, I get a positive 5. A2 subtract A1 here is going to give me 1A left. B3 subtracting B1 gives me B squared left. That would be my final answer left over, okay? So the GCF is always attached outside brackets, okay? Just because you divided it out doesn't mean you can forget about it. Because when we want to check our work to make sure we did it right, we would multiply it back in. So we would do a 1 by 2 box, or we would just do what's called distributive property. So we would just multiply it back in and check our work. Okay, that's how you check your work. Okay? Now remember, when we multiply, we add exponents. When we divide, we subtract exponents of like variables. Okay? So we got to remember our variables. Let's take a look at B and C. Give those a try. Okay, let's see what you come up with. Between 18 and negative 24, you can take out a 6. How many your least amount of x's is x cubed? Your least amount of y's is y squared. So 6x cubed y squared would be the GCF coming out. On the next set, and remember, it's got to go into all 3 of them. These ones can be divided by 10. But since they all have a negative in front, you're actually going to divide the negative out with it. So you're going to divide negative 10 out. Now, what is the least amount of A's that can come out of there? 2. How many B's? 1. Good. Only B1 because this guy has a B1 there. Okay? That would be your GCF coming out of that one. Let's take a look at how they would actually look now if we actually put them in brackets. Okay? So, all of these guys can divide by a 5. Now, when there's more than one term, I like to put it right underneath each of them so I don't forget to divide them. What is your least amount of W's that can come out? 2. Good. So W squared is on the bottom. Okay, so my final answer is going to have 5W squared as my GCF. It goes on the outside of brackets. Now I divide, and the answer goes inside. So 15 divided by 5 is 3. How many W's left? 2. Good. W squared. Over here, 5 divides by 5 how many times? Positive 1. The W's disappear because 2 subtract 2 is 0. So on this one, the W's completely disappear. Do you have to write W0? No. It just completely disappears. So no more W's there. Over here, 25 divided by 5 is a negative 5. And how many W's left over when you subtract them? 1. Good. So 1 W on the left. So your inside would be 3W squared plus 1 minus 5W. Let's try the next 2. Give it a try on your own. Push pause now and play when you're ready. Okay, for these ones, the first thing you should divide it by, all these divide by 6. Our lowest value of x is x squared. So I'm going to divide each of them by 6x squared to give me 6x squared comes on the outside as my GCF. And on the inside of brackets, I end up with 3x squared plus 4 minus 9x. Check your work. Remember, when you're dividing, you subtract the letters, okay? So subtract your exponents on your variables. On the second one, the middle guy, the x squareds, they cancel, they drop. Okay, they disappear completely. If you have the same amount on top, the same amount on the bottom, they disappear completely. Divide by 12, 18 doesn't divide by 12 evenly without giving you a decimal. The next question, yes. The next question, you divide them all by 12. Okay? Now, if you didn't divide by the 12, let's say you divided by a 6, you just have to refactor everything in those brackets again and divide something else out. How come? Because you can't leave your answer as having another factor available to be divided out. It has to be the simplest form. So we take a look, our smallest amount of x's is x1. Our smallest amount of y's is y1. We're going to divide out 12xy to each of them. So 12xy is my GCF. Again, it's on the outside of brackets, and the answer to dividing is on the inside. So 36 divided by 12 gives me a 3. I have 1x left and 3 y's left. Okay, so you have to subtract them. 60 divided by 12 gives us a 5. I have x squared left because my y's cancel. They disappear here. On the next one, my x's disappear. They cancel. So I'm going to get a negative 7, and beside him, I'm going to get y squared. Negative 7y squared should be on the end. Okay? So the inside is 3xy cubed plus 5x squared minus 7y squared. A little squishy there on the end. That's our first type. So we've got greatest common factors. Our second kind of factoring is called difference of squares. Okay? Difference of squares. Now, what the heck's the difference of squares? Well, the word difference means there must be a subtraction sign between them in order to use them. Or another way of thinking about it is to say they've got to be opposite signs. So you need two numbers or two terms. Okay, so you need two terms to deal with, and they need to be opposite signs. Those are the two things that you need to happen if you're going to do a difference of squares. Okay? So, doing the first example, I'm just going to do this one. I'm going to go x squared minus 1. I'm going to square root them. How come? It's a difference of squares. So this one right here, the x squared has a hidden plus sign in front of him. So he's positive, the one is negative. Opposite signs. There's two terms, okay? And we typically want the negative sign in the middle. Let's say it was written like this. It could also be written this way. We could add negative 1 plus x squared. Can we still factor that? Yes. You just rewrite it to look like this. Okay, you want the negative sign or the subtraction sign in the middle. Okay? Now squares, the reason it's called a difference of squares is because you can square root both ends. When you square root 1, square root of 1 is just 1. So 1 can be square rooted down very low compared to what you start with. When you square root a variable, you divide the exponent by the index. That's how you square root a variable. So if I was to go x to the 5th power, how do I square root him? I would have to go 5th power of x exponent 5. Opposites cancel, you will get x. Okay? That's why it's called difference of squares. We're using square root signs. So we have a lot of things that are squared. So x squared, how would I get rid of him? I would square root, because I have a hiding index of 2. Square root sign disappears, so does the square root sign disappear. I get an x left over that goes in my brackets. Okay? So when I square root both ends, okay? So the second step says open two sets of brackets, square out your first term, he goes in the first spot in each bracket. Square out the second term, he goes in the second spot in each bracket. Then you separate your terms with positive negatives. That's all it is. So up here, I would open two brackets like it tells me. I square root x squared and got x to start. I square root 1 and I get a 1 to put on the end of my brackets. And then you just separate with a positive negative. That's all it is. Okay? That's called difference of squares. Let's take a look at a few examples. Okay, here's a few of them to try together. So, the first thing you always do though, every time, no matter what, is look and see if you can divide a GCF out. Okay, that's always your first step, is GCF. Is there one? If there is, you got to check and see and divide it out. 4 and 9, there's no GCF. They don't divide by a number that will give you a round answer. You cannot be rounding a decimal. So you have to have an even answer that does not divide into a decimal. So instead, you just square root both ends. Open 2 brackets. What is the square root of 4? 2. Square root of x squared. X. What's the square root of 9? 3. And now you just separate them with positive and negative signs. So positive, negative, you're finished. That's all it is. Okay, it's one of my favorite kinds because they're the easiest you'll ever deal with. Okay. Now if we take a look at number 2. Number 2 has something going on. What do you notice about the way it's written? The negatives out front. So first of all, we're going to flip-flop them. So this is actually 16x to the 4 minus 64y squared. All right. Is there a GCF I can divide out of there? Well, if I divide 8 out, though, what happens to 16? It becomes a 2 in front, and is the 2 a perfect square? No. If I divide him by 8, I get an 8, but is the 8 a perfect square? No, neither of them are perfect squares. So I need to see if there's a different number lower that I can divide them by, where the answers still stay as perfect squares. Does 64 divide by 16? What do you get as an answer? What's that? You get a 4, don't you? Okay, 64 times 4 is 64, correct? Okay, so if I divide them both by 16, I still get a perfect square over here. And that's what we want to do. So we're going to divide by our GCF first. So I'm going to divide both of them by 16 first. So now it's going to look like x to the 4 minus 4y squared. Okay, now I can start. So the first thing you're going to do now, again, open 2 sets of brackets. The 16 you divided out needs to stay in front attached. That's your GCF you divided out. He has to stay attached. Now we square root both ends. Remember, when we square root variables, all we do is we're cutting the exponent into half. We're dividing it by 2 because the index is a hiding 2. So you're dividing it by 2. So 4 divides by 2 and gives me x squared. Okay, so x squared starts our brackets. What's the root of 4? The root of 4? 2. What is the root of y squared? Y. Good. So I have 2y on the ends of both. And now I just separate both of the positive negative. That would be my final answer. You cannot go any further unless they tell you what either x or y are. Okay? Now, do you notice one of them still has a subtract sign and a squared? The one on the far right still has a squared sign and a subtraction. I have to look at this one again. I need to look at him to see if both of them are perfect squares. Well, I know that x squared is a perfect square, but is 2y a perfect square? No. If it was, I would take it even lower, but it's not. That one doesn't go any lower. Okay, so that would be my final answer with all of this written together. Okay, let's take a look at number 3 on the top. What do you notice I can divide out of number 3? I can divide it all by 2. So I'm going to have 2 and then an x to the 4 minus 16. All right, next step. Open 2 sets of brackets. The 2 in front stays in front. Now we square root. What is the root of x exponent 4? X squared. Good. So x squared starts your brackets. What is the square root of 16? 4. Good. 4 at the end. Now separate with plus and minus. Now, do you look again at the one that's got a squared sign and a subtraction in the middle? So you can never factor the ones with the plus sign. The ones with the plus sign, you can never factor these further. They're done. But the ones with the negative sign in the middle, you need to take a look at those ones. Because if they're both square roots on both ends, you can go further. And these ones are. I can square root both of them, so I'm going to. You have to take it as low as you can go, or it's not fully factored. So now this one's going to open 2 brackets. And what is the root of x squared? X. What is the root of 4? 2. And then you're going to separate with positive and minus sign. Now, what was attached in front needs to stay attached. So that means our 2 comes down, and so does our x squared plus 4. It stays attached. So now our final answer is going to have that 2 in front, and then 3 sets of brackets behind it. Is that okay? Absolutely. You can go as long as you can. Okay? So, we're going to do another example where we're going to take it low, 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 and further, okay? Let's take a look at number 4 first. Okay, on number 4, there's a plus sign between them. Can I factor that? Now, you might think you can, but the reason it's called a difference of squares is the terms have to be opposite signs. The 25 has a hidden plus sign in front of him, and there's a plus sign between them. So we would say this guy is not factorable. Unless we can divide out a GCF. Otherwise, he's not factorable. Okay, not at all. And how come? Again, it's because of that plus sign. Now, instantly, because you see the 25 and the 81 and some x squared, y squareds, a lot of kids first will do this. They'll go, okay, well, I can square root both, open 2 brackets, I'm going to get 5x at the front, and then I'm going to get 9y at the end, and they're both pluses, so they both get pluses. That isn't correct. Because if I were to box that and multiply it back out, or FOIL it back out, I'm going to get the 2 end ones. I get this, 25x squared and an 81y squared, but then I'm also going to get a middle term. My O and my I give me middle terms. 5 times 9 is 45. So I'm going to get a plus 45xy and a plus 45xy, and they're not going to cancel. If that was a minus sign when you multiplied it out, you get a positive and a negative, so they cancel out and give you no middle term. Here, they're both positives. So your middle term would actually be 90xy. And is that what I have to start with? No, you don't. You have a binomial with a plus sign. This will give you a trinomial answer. You'd have 25xy, or sorry, x squared plus 90xy plus your 81y squared. That's why the ones with the plus sign in the middle do not work out. Okay? They do not work out on purpose because of that. Okay, now we see some fractions. It really doesn't complicate things. When it's a fraction, all you've got to do is square root the top and the bottom separately. And then that's what starts and ends your brackets. So, again, you open 2 brackets. I'm going to square root this guy, which means square root the 1 and the 9. So it's going to give me 1 over 3 in front. Okay? Square root x squared gives me x beside the 1/3. Okay? Then I square root 64 to get 8 that goes to the back. And now you can plus minus them. Okay? Separate with a positive and a negative. I want you to give number 7 a try. Give number 7 a try. And number 8 a try. 7 and 8 are identical to that. Well, let's take a look at 7 and 8. First thing again, open 2 brackets. Square tops and bottoms. 3 over 7 starts. 5 over 9 is the end. Root of x4 is x squared. And separate with positive and a negative. Okay? On number 8, same kind of thing. We're going to open 2 brackets. Square root tops, square root the bottoms. We're going to get x over 8 to start. At the back, y over 7. And separate with positive and subtraction sign. Okay? Number 6. What do you notice about number 6? You can take out an x. Good. So you're going to divide an x out. That's your GCF. Okay? So we get x bracket. Now we have w squared y squared minusing x squared z squared. Now we can open two brackets and finish that one. Okay, give number 6 a finish there, guys. Okay, so opening that guy up. We'll just bring him down here. Open two brackets. Now I square root my letters on both ends. When you square root them, remember, you divide them in half. So I'm going to get WY at the start, X, Z at the back, and you separate with a positive and a negative sign. Okay, that's our difference of squares. Now we're going to get into some trinomial factoring. If you remember how to do these guys, we need to factor trinomials. So this is where we use our diamond. Okay, so trinomials, before you can actually factor them, they must be written in descending order. That means largest exponent to no exponents, meaning no variable. So you're always going to start with your x squared, then your x, then your constant. Okay? The a factor is always sitting in front of the x squared, the b factor sits in front of x, and the c is called your constant. He doesn't have a variable. So how do we find what numbers to put in your diamond? Well, the top of your diamond is always a times c. So don't forget, your a here is a hidden 1. So 1 times 2 is going to give me a 2 on top. The bottom is a 3, your b number. Now what we actually do is we have to factor the number 2. We factor the a times c. Okay? So factor a times c, which is a 2. Well, what numbers multiply to give you 2? 1 times 2. Good. So 1 times 2 is what I get. So I'm going to put a 1 and a 2. Now I need to check those. When I add them, do I get 3? Yes. So what happens now is you open two sets of brackets. You square root x squared, of course, and put him in the front of both brackets. And then the numbers on the wings of your diamond that you found, those go at the end of your brackets. So 1 and a 2. Now check your signs. Are they both positives, both negatives? The 3 in the middle is a positive. So they're both going to be positives. Okay, because the 3 and the 2 are both positives. Okay, so they're both positives. Let's take a look at a few more examples. Everybody got that written down? Pretty close? On the first set, again, on the very top, we have a times c. So you have to identify who a, b, and c are. So here I've got an a who's a 1, a b is 8, a c is 12. Well, on the top of my diamond, I take a times c. 1 times 12 gives me 12. My b number goes in the bottom, who is an 8. Now I got to factor 12. So the factors of 12. 1 times 12, 2 times 6, 3 times 4. Which ones add to 8? 2 and 6. That's why I'm going to choose the 2 and the 6, because when I add them, they give me the bottom number. So my wings of my diamond now become a 2 and a 6. Okay? So now you're going to open two brackets. X starts your brackets. The 2 and the 6 go at the end. And again, they're positive, so put a plus sign between them. Okay? If we take a look at B, B is very similar because I'm using the number 12. Well, I would do the same thing as I did over here. I need to factor 12. Okay? So I've got 12, a times c. 1 times 12 is 12. On the bottom, I have a 13. So what number is going to go on my wings now? Well, here's my factors of 12. Which two digits add to 13? 12 and 1. So you're going to use 1 and 12. Those are the numbers that go in the brackets this time. So now you're going to have x plus 1 and x plus 12. Any questions? Okay, take a look at C and D now. Again, I've got an A value of 1. So 1 times 10 gives me my 10 for A times C. The B goes in the bottom. He's a negative 11. Okay. Whenever you've got a negative in the middle and a positive on the end, two negatives multiply to give you a positive. That means both of your numbers in the wings are going to have to be negative values. Okay? So now I've got to factor the 10 again. I always factor A times C. Okay, so I factor A times C. So factors of 10, 1 times 10, 2 times 5. Which ones add to give me 11? 1 and 10. So, since this guy here, the 11 is a negative, they're both going to become negatives. So I'm going to have a negative 1 and a negative 10. So now you're going to open your brackets, and instead of x, we have letter A this time. So we're going to have A minus 1 and A minus 10. Okay, check your work. Okay, let's take a look at D. I have a hidden 1 for an A value again, so A times C gives me 4. My B value in the bottom is 3. So I need to factor A times C. So 4, my factors of 4. 1 times 4, 2 times 2. They're all positives. So I know that I'm going to have a positive on this wing and a positive on this wing. Do any of those factors add to give you a 3? None. Because this guy's going to add and give you a 5. That guy adds and gives you a 4. So in the middle, I could have a 5 or a 4, but I have a 3. So I would say this guy is not factorable. Okay, I can't do it. Because the only other numbers in the middle should be 5s and 4s. You can't get a 3. Unless one of them is a negative and the 4 is a positive. Okay? Okay, the only thing that makes this more complicated is dividing by your greatest common factor. So we're going to divide out a GCF first. So what is my GCF that can come out of all of them? A 4. Okay? On the right, what can come out of all of them on B? A 3, and what else? An x1. Good. You always want it to be x squared, then an x, then no variable. So if there's a variable in all of them, you're probably likely going to be dividing out one of the variables. So the first one's going to look like this. 4 x squared minus, what's 32 divided by 4? 8 x, what's 48 divided by 4? Good, 12. So now I've got my new trinomial. My new trinomial, again, will have an A value of 1. Okay, now I'm able to open my two brackets. Only the GCF must come down and sit in front of both those brackets. Okay, since the brackets are attached, the 4 only times to the outside bracket on the left. Now again, you're going to do the factors of 12, A times C. So A times C up here is 12. My middle is a negative 8. Since my middle one's negative and the 12 is a positive, I need 2 negatives to multiply to give me a positive, and they add to give me a bigger negative. So what are the factors of 12 again? If I factor 12, I get 1 times 12, 2 times 6, 3 times 4. Which ones give me a negative 8? 2 and 6. Good. So it's going to be negative 2 and negative 6. They both have to be negative. So again, what starts my brackets? X starts both of them. On the end now is what I have in my wings. Minus 2, and I have a minus 6. That would be my final answer. I can't go any further. Okay, you guys try B. We already know we have to take a 3x out. Okay, you guys try B. Okay, let's say that you got a 3x come out. Then you're going to get x squared plus 7x plus 10. Now, we know that the factors for 10 are 1 times 10, 2 times 5. Which ones add to give you 7? 2 and 5. Okay. So I know my wings are 2 and 5. My A times C is 10 on top. And my middle is, my B is 7. Okay? That tells you the wing numbers are the ones that go in the brackets. So now I'm going to open two brackets again. That 3x, my GCF, has to stay out front of my final answer. And now I put the numbers in the wings. I have a positive 2 and a positive 5. Okay, that would be your final answer. But yes, the 3x out front must stay attached to your brackets. Okay? It doesn't get written in front of both of them because they're sitting side by side. It only needs to be written in front of the first set of brackets. Okay? There's no plus sign or subtraction sign between the brackets either. They sit side by side. All right. Now we're going to do all of this when A, the A number, we've been dealing with A as 1. Now we're going to make A a different number. We're going to make them bigger than 1. So what happens if he's bigger than 1? Well, we have to follow a few steps. And the only thing that's different this time, everything's the same, is once we find our wing numbers here on the left and the right of our diamond, once we find them, we need to divide by the factors of A. So when we start our brackets, that's my A. So 2 is my A. So you have to factor 2. What are the two numbers that multiply to give you a 2? 1 and 2. Okay? So the factors of 2 are 1 times 2. That's what's going to start my brackets. Okay, the factors of A. Okay, your factors of A. And again, you're checking. Can you divide out a GCF? In this case, nope, no GCF. Okay, so we know our brackets are going to start. Factors of 2 are 2 and 1. Factors of x squared, I put my x down beside my 2 and my 1. So now I've got my factors of A. And that's what I divide my diamond numbers by. I'm going to divide them by the 2 and by the 1. But when I divide them, I need to divide them and make sure that they don't give me a decimal answer. That's how you know who divides by who. Okay? All right, let's do A times C. A times C, 2 times negative 9 gives me a negative 18 on top. And my middle number is a negative 3. Well, what are my factors of negative 18? 1 times 18, 2 times 9, 3 times 6. Now, since our B number is a negative, if the B number is negative or positive, it's always going to tell you what the large number is. Because the large number in the factors takes the sign of the B guy. The B guy is a negative, so that means our big numbers here are going to be negative. So it's going to be 1 times negative 18, 2 times negative 9, 3 times negative 6. And when you look at those combinations of numbers now, which ones give you an add up to negative 3? 3 and negative 6. So now I know the numbers on my diamond are going to be a 3 and a negative 6. Okay? So my diamond numbers are going to be a 3 and a negative 6. Now, before with our trinomials, we would just stick that 3 and the negative 6 in our brackets. We can't yet, remember. We can't do that because we've got to divide them by the A value. So I've got an A value of 2 and I've got an A value of 1. Which one is going to divide by the 2, the 3 or the 6? The 6, good. So if I divide the 3 by the 2, I get a decimal. And you can't get decimal answers when you divide them. So I'm going to divide the 6 by the 2 and the 3 by the 1. Now the trick is putting them back in the brackets. When you put them in the brackets, you put them in the number who didn't divide by them. So the 3 divided by the 1, so the answer to that dividing has to go in the bracket with the 2. You can't go in the bracket with the guy you divided by. Okay? So the answer to 3 divided by 1, which is 3, is going to go in the bracket with the 2. Okay? He's going to go in that bracket. And he's a positive 3. Over here, I've got a negative 6 divided by 2 is going to give me a negative 3, but I cannot put him in the bracket with the 2. He's going to go in the bracket without the 2. So I get a negative 3 there. Okay? Now I can check my work. I'm going to check my smiley faces. My smiley faces for FOIL are called my O and my I. So if I check these guys, there's my O, the outside terms, and here's my I, the inside terms. Check your O and I. When you multiply them, then add them, they have to give you the middle term here, negative 3. So, my outside, 2 times negative 3 gives me a negative 6x. 3 times 1 gives me a 3x. Negative 6 plus 3 gives me my negative 3. That means I did it right. Okay? So you need to check your work on these ones. All right, here we go. Last 4 examples. First thing I'm going to do is I'm going to factor my A. Here's my A, it's 2. So when I open my brackets, I know I'm going to have a 2x and a 1x. Those are my factors of A. Okay, so that's what I'm going to start with so I know what my factors of A are. Okay? Now I'm going to take my A times C and put it on the top. A times C is 6 times 2 gives me 12. to the top of my diamond, and I have a 7 for a b value on the bottom. What numbers multiply to 12 and add to 7? Let's factor 12. 1 times 12, 2 times 6, 3 times 4. Which ones add to 7? 3 and 4. Good. So 3 and 4 go on my wings, but they don't go in the brackets yet. They need to divide by the 2 and the 1. The 4 is going to divide by the 2, the 3 is going to divide by the 1. Otherwise, we get decimals. That's why we have to divide those ones specifically. The 3 divided by the 1, so he's not going to go his answer in the 1 bracket. He'll go with the 2. Positive 3. The 4 divides by 2 and gives me a 2. He goes in the bracket without the 2. And that's what I fill in my brackets. Okay? Now, again, check your smiley faces. Your outside terms. 2x times 2 will give me a 4x. My inside, 3 times 1x gives me a 3x. 4x and 3x, do I get my 7x? Yes, I do. So I did it right. Okay? Let's try letter B. Take a couple minutes and try B on your own. All right. Our A is a 5, so I'm going to factor the 5. And I'm going to get a 5x and a 1x. Those are my factors of 5. Now I go to my diamond. A times C gives me 10. 5 times 2. My B is a 7. Factors of 10. 1 times 10. 2 times 5. Which ones add to 7? 2 and 5. Okay. 2 and 5. I've got a factor of 5 and a factor of 1. Which ones divide by which? 5 divides by the 5, and the 2 divides by the 1. Good. All right. 5 divided by 5 gives me a positive 1. He has to go with the guy with the 1. He can't go in the bracket of the guy he divided by. 2 divided by 1 gives me a 2. He's going to go in the last part. Now we check our smiley faces. Let's check and make sure we did it right. Outside, 5 times 1 gives me a 5x. Inside, 2 times 1 gives me 2x. 2x and 5x, do they give me a 7? Yes, they do. So we did it right. Okay? The bottom is done the exact same way, only now we've got some negative numbers. So, again, your first step is always check if there's a GCF. In the first one, there's not, but on letter D, there is. Letter D, there is a GCF of 5 that you can divide out. Okay, so give C and D a shot. Give those a try. Okay, let's take a look at the last two. Again, we need to factor our A. So I'm going to have 2x and a 1x. Let's move those down. Okay. In my diamond, I'm going to have A times C to give me a 6. And I've got a negative 7 on the bottom. Well, if I've got a negative and I have a positive on top, that means two negative numbers are going to multiply to give me a positive. Okay, so they both have to be negative. So I need to factor 6. 1 times 6, 2 times 3. If they're both negative, which ones add 7? 1 and 6. Good. So negative 1, negative 6. So I have a negative 1 and negative 6. So which guy is going to divide by the 2? The 6. Good. So since I take the negative, or so the negative 6 and divide by 2, his answer goes with the 1. You can't go in the same bracket of the guy you divided by. Negative 1 divides by 1, and he's going to give me a negative 1. Check your smileys. Negative 6x, negative 1x. Do I get my negative 7? Yep, I sure do. On the right-hand side, we need to take a GCF of 5 out. When we do that, I'm going to change k to x for a moment. I get 3x squared plus x minus 2. Okay, that's my new equation, or my new expression. Now I'm going to take that guy and factor him. The 5 stays attached, and I open 2 brackets. What are the factors of A, who is now my 3? What are the factors of 3? 3x and 1x. Good. All right. So now my A times C, here's your A, your B, and your C. Your B is a hidden 1 there. So you get a negative 6 and a positive 1 on the bottom. So again, we've got a negative 6. Which one is going to give me a positive 1? So I've got 1 and 6, 2 and 3. My bottom number is a hidden positive. That means my big number's positive, my small number's negative. When you add them, which one gives you a positive 1? Negative 2 and positive 3. So negative 2 and positive 3 go to my ways. Now I divide them by the 3 and 1. Who divides by 3? The 3. Good. And the 2 divides by the 1. All right, so I'm going to get a plus 1 and a negative 2. And again, check your smiley faces. And yes, it'll work out. Okay? This concludes 2.0 factoring review.